That's from number 21. Sorry, from number 22. Let's continue the exercise from number 22. Now, this is a geometric progression. The question says, okay, we don't know yet whether it's a geometric or an arithmetic progression, but the question says that the nth term, un of a sequence is given by un is equal to 3 times 2 raised to power n minus 1. The nth term of a sequence un, this is the nth term, is given by 3 times 2 raised to power n minus 1. So we can also say un is equal to tn, nth term is 3 times 2 raised to power n minus 1. Now this means u1, the first term, will be 3 times 2 raised to power 1 minus 1, which will give us 3 times 2 raised to power 0, which will give us 3 times 1, 3. So that means also the second term will be 3 times 2 raised to power 2 minus 1, which will give us 3 times 2 raised to power 1, which will give us what? Which will give us 6. Now also the third term u3 will be 3 times 2 raised to power 3 minus 1, which will give us 3 times 2 raised to power 2, which will give us what? 3 times 4, which will give us 12. And u4 will be equal to 3 times 2 raised to power 4 minus 1, which will give us 3 times 2 raised to power 3. 4 minus 1 is 3, which will give us u4 is 3 times 8, which will give us 24. Now, this means that our u1 first term will be what? 3. Our u2 second term will be what? 6. Our u3 third term will be 12. And our u4 fourth term will be 24. Now, let us look at this very well. What kind of progression does this look like? What kind of progression does this look like? 3, 6, 12, 24, and so on. This looks like a geometric progression with common ratio 2. It says, the question says that we should write down the first 4 terms of the sequence. So we have successfully written down these first 4 terms of the sequence like that. Now, Roman numeral 2 now says, this is question A. Let me number it well. This is question A of 22, and this is Roman numeral 1 of question A. Now, let's go to Roman numeral 2. Question A of 22, Roman numeral 2 says that we should find the least value of n for which un is greater than 9,000. We should find the least value of n for which un is greater than 9,000. Now, let's take this slowly. When un, this kind of GPs are called miscellaneous GPs. These kind of progressions are called miscellaneous progressions. Some of them will lead to a GP, some of them will lead to an AP, some of them will not lead to what looks like an AP or GP, but we will be looking at them very carefully. Now, we want to look for the value of n for which un is greater than 9,000. So that means we want to look for the value of n for which our nth term un will be greater than what? 9,000. So here we say when un is greater than 9,000, it means doing 3 times 2 raised to power n minus 1 will give us an answer greater than 9,000. And here we could divide both sides by 3. If we divide both sides by 3, 3 will divide 3 here, 3 will divide 9,000 and give us 3,000. So that means we could say 2 raised to power n minus 1 is greater than what? 3,000. 2 raised to power n minus 1 is greater than 3,000. So here, 2 raised to power n minus 1 is the same thing as 2 raised to power n divided by 2 raised to power 1. So that is what is greater than 3,000. 2 raised to power n divided by 2 raised to power 1 is the same thing as 2 raised to power n over 2 raised to power 1 greater than 6,000. We could cross multiply both sides here. We could cross multiply here. We will get 2 raised power n times 1, 2 raised power n times 1 here, 2 raised power n times 1 here, 2 raised power 1, and we could do 2 raised power 2 times 3,000 will give us 6,000. So that gives us 2 raised power n is greater than 6,000. Now, to look for the value of n here, we need to take log of both sides. So that means log 2 raised power n will be greater than log what? 6,000. So that gives us n log 2 is greater than log 6,000. Let's not forget both bases are to, both numbers or both sides are to base 10. So that means our n will be what? Greater than log 6,000 divided by log 2. And that gives us n greater than 12.56. We need to do a small inspection here. Let's assume that n is equal to, our n is greater than 12.56. If n is greater than 12.56, we could easily guess that n will be something from 13 upwards. But let us just check. When n is equal to 12, what's the value of un? When n is equal to 12. When n is equal to 12, our un will be 3 times 2 raised to power 12 minus 1. And that will give us 3 times 2 raised to power 11. 3 times 2 raised to power 11 will give us 3 times 2,048. And that gives us what? 6,144. 6,144 is not greater than 9,000. So that means the value of our un for which, that means the value of our n for which un is greater than 9,000 is not 12. But let us try n is equal to 13. Let's see. When n is equal to 13, our un will be 2. Our un will be what? 3 times 2 raised to power n minus 1. So our un will be 3 times 2 raised to power 13 minus 1. That will give us our un as 3 times 2 raised to power 12, which will give us 3 times what? 4,096, which gives us 12,288. Definitely 12,288 is greater than 9,000. So that means the least value of our n for which un is greater than 9,000 is what? 13. The least value of our n for which un is greater than 9,000 is what? 13. That solves the question. That solves the question in number 22a, Roman 1-2. Now, let's go to number 22b. Let's go to number 22b. Now, here in number 22b, the question says the fifth term. Let's go to number 22b. The question says the fifth, ninth, and 16th terms of an AP. In an AP, nth term is equal to a plus n minus 1d. So that means the fifth term is a plus 5 minus 1d. That will give us what? A plus 4d. The fifth term, the ninth term will be a plus 8d. And the 16th term of the AP will be a plus what? 15d. Let me write this well. Let me just correct this and write it very well. A plus 15d. So that means this is our fifth term, ninth term, and 16th term of the AP. It says that the fifth, ninth, and 16th terms of an AP of a linear sequence are consecutive terms of a GP. If these terms are consecutive terms of a GP, that means T5, T9, and T16 of the AP are consecutive terms of a GP, which means that A plus 4D, A plus 8D, and A plus 15D form what? A what? Form a what? A geometric progression. Now, if these three expressions form a geometric progression. What it means is very simple. It means that there's a common ratio between a plus 4d, a plus 8d, and what? A plus and what? A plus 15d. So that means my common ratio will be a plus 8d over a plus 4d. My common ratio will also be the same thing as a plus 15d over a plus 8d, which means that if I cross multiply here, which means that I could write that my common ratio is a plus 8d over a plus 4d, and also write that my common ratio, which is equal to what? A plus 15d over a plus 8d. So that means I could equate these two, a plus 8d over, let me highlight that, a plus 8d over a plus 4d. I could equate it to a plus 15d over a plus 8d. I could equate it to a plus 15d over a plus 8d. Now here I'll cross multiply. When I cross multiply here, what do I get? I'm going to get a plus 8d times a plus 8d. That gives me a plus 8d squared, as in here. That gives me a plus 8d squared is equal to a plus 4d times a plus 15d. Now on expansion, this will give me a plus 16ad plus 64d squared is equal to what? A squared. Sorry, this will give me a squared plus 16ad plus 64d squared on the left here is equal to a squared plus what? Plus 19ad plus 60d squared. So that means a squared and a squared could cancel each other from left to right, and I have 16ad plus 64d squared is equal to 19ad plus 60d squared. So here I can simplify to get 16ad minus 19ad will give me 60d squared minus 64d squared. So that means minus 3ad will give me what? Minus 4d squared. Let me repeat that here. Minus 3ad will give me minus 4d squared. So d, divide both sides by d. I can divide both sides by d because d is common to both sides, or minus d, so to speak. I will get 3a is equal to what? 4d. So that gives me my a as what? That gives me, okay, I'm supposed to write d in terms of a. The question says that I should find the common difference in terms of I should find the common difference of the linear sequence in terms of the first term. So that means I'm writing d in terms of a. The question says I should write d in terms of what? A. So let me rearrange this equation. 4d is equal to 3a, and d will be equal to 3a over 4. So that's the first part of number B, Roman number 1. So let me now go to B, Roman number 2, 22b, Roman number 2. This was 22b, Roman number 1. This was 22b, Roman number 1. Let's continue with 22b, Roman number 2. It says as you show that the 21st, 37th, and 65th terms of the linear sequence are consecutive terms of an exponential sequence whose common ratio is 7 over 4. Now, this linear sequence here that has the relationship between its a and d as d is equal to 3a over 4. I am to show that for that AP, the 21st term, the 37th term, and the 65th term of that AP also form consecutive terms of a GP. Now, what is the 21st term of this AP? The 21st term will be A plus 20D. That will give me T21 is A plus 20D. That will give me T21 is A plus 20 times. My common difference is 3A over 4 from here. My common difference from here is what? 3A over 4. So I will move it over to this place. That gives me my T21 as A plus 4A1, 4A5, A plus 15A, which will give me 16A. So my T21 is 16A. Also, my T37, let me also find T37. My T37, which is the 37th term of the AP, is what? A plus 36D. So that will give me A plus 36, open bracket, 3A over 4. Also, the common difference of the arithmetic progression is given by 3A over 4. 4A1, 4A, 4A1, 4A, 9. 4A1, 4A, 9. So that will give me A plus 27A, and that gives me 28A. So my T37 is 28A. Let me find also T65 of this new GP, or T65 of the AP. T65 of the AP will be given by A plus 64D. That will be A plus 64, open bracket, 3A over 4. That will give me 4A1, 4A, 16. And that gives me A plus 48A, which will give me 49A. So that means my APs T21, my APs T21, my APs 21st term, 35th term, 37th term, my APs 21st, 37th, and 65th term are 16A, as what? 16A, 28A, and what? 49A. So now let's look at this very well, how they form a GP of common ratio 7 over 4. Now, if this form a GP, that means the common ratio of that GP will be, if these numbers form consecutive terms of a GP, if these three values, if these three terms of my arithmetic progression form consecutive terms of a GP, what it means is that the common ratio of that GP will be R is equal to 28A over 16, which will be equal to what? 28 over 16A, which will be equal to 7 over 4, or R is equal to 49A over 28A, which will also give me what? 7 over 4. So this means it is true that it is true that the 21st, 37th, and 65th terms of my AP form consecutive terms of a GP whose common ratio is what? 7 over 4, as I have shown you. That solves the question in number 22B, Roman number 2. Let's now go to question 23. Let's go to question 23. Now, in question 23, this ends question 22. In question 23, we are told that the sum of the first n terms of a sequence, Sn of a sequence, is given by 20 minus 10 over 2 raised to power n minus 1 for all values of n greater than or equal to 1. Now, if this is the sum of the first n terms of a sequence, the question says we should find the sum of the first 5 terms. That means sum of the first 5 terms is S5. S5 will be equal to 20 minus 10 over 2 raised to the power 5 minus 1. That will give me S5 as 20 minus 10 over 2 raised to the power 4. That will give me S5 as what? 20 minus 10 over 16. This will give me S5 as 20 minus 5 over 8. 20 minus 5 over 8 is the same thing as 20 over 1 minus 5 over 8. This will give me 160 here minus what? Minus 5. And that will give me 155 over 8. 155 over 8 gives 19 whole number. 155 over 8 gives what? 19 whole number 3 over 8. So that means the sum of the first 5 terms of that sequence is 19 whole number 3 over 8. Let us keep that there for number 23a. Now for question 23b, let's go to question 23b. Excuse me. Let's go to question 23b. For question 23b, we are told to find the fifth term of the sequence, T5 of this sequence. Now, we know that T1 plus T2 plus T3 plus T4 plus T5 will give us the sum of the first 5 terms. Let me rewrite this to make it clear. We know that the sum of the first 5 terms, S5, will be equal to T1 plus T2 plus T3 plus T4 plus what? T5. Now, if this is the sum of the first 5 terms, it means the sum of the first 4 terms will be only T1 plus T2 plus T3 plus T4. So here, this gives us some of the first 5 terms. Here, this gives us some of the first 4 terms. That means if we want to find the fifth term alone, we could easily say that S5 minus S4 here on the left hand side here is the same thing as what? T5. Because here if we subtract this, excuse me, if we subtract this from the top here, if we subtract the second line from the first line, we will get T5 fifth term is S5 minus S4. So that means my fifth term, that tells us that my fifth term is the sum of the first 5 terms minus the sum of the first 4 terms. So here it means I still have to find the sum of the first 4 terms. So my S4 will be given by what? 20 minus 10 over 2 raised to the power 4 minus 1, which will give me S4 as 20 minus 10 over 2 raised to the power 3. Let me write that 3 1. That will give me 20 over 1 minus 10 over 8. And that gives me what? 20 over 1 minus 5 over 4. 480 minus 5. That gives me S4 as what? 75 over 4. 75 over 4. So that means my fifth term, which I said will be given by sum of the first 5 terms minus sum of the first 4 terms, will now be what? 155 over 8 minus, will be 155 over 8 minus 75 over 4. LCM is 8. 155 minus 150. This will give me 5 over 8. So the fifth term of the sequence is what? 5 all over 8. That solves the problem in question 23b. Let's move on to question 24. In question 24, we are told that the sum of the first n terms of a series is given by Sn is equal to 5n squared minus 2n. And for the same sequence, okay, the sum of the first n terms of a series is given by Sn is equal to 5n squared minus 2n. And now there is a sequence that has first term, second term. There's another sequence that has first term, second term, third term, and so on, which is defined by UR is equal to SR minus SR minus 1. This is just like saying the third term is defined by sum of the first four terms. The third term will be found by sum of the first four terms minus sum of the first three terms, just like what we did, just like what we just completed in number 23. So here, the question says we should express UR. This is question 24a. The question says we should express UR, that means the rth term, in terms of R in its simplest form, and show that the sequence is a linear progression. This is a very simple question. What we just need to do is that we should remember that if UR is SR minus SR minus 1, it means UR will be the same thing as SR. What will SR be? Since Sn is 5n squared minus 2n, SR will be 5r squared minus 2r, and SR minus 1 will be what? 5r minus 1 squared minus 2r minus 1 minus 2r minus 1. Let me write that very well. There should be two brackets there. I have to really squeeze it up to make this space contain it. Minus 2r minus 1. That makes it look okay. So that means my UR will be 5r squared minus 2r. My UR will be 5r squared minus 2r, which conforms with 5n squared minus 2n, minus my SR minus 1 will be 5r squared, will be 5r minus 1 squared, 5r minus 1 squared minus 2r minus 1. Now, what does this give me? This gives me my UR. This gives me my UR as UR is equal to 5r squared minus 2r minus 5r minus 1 squared minus 2r minus 1. So let's now simplify this. This will give us 5r squared minus 2r minus open bracket 5. What is r minus 1 squared? Will give me r squared. Will give me r squared minus 2r plus 1. Will give me r squared minus 2r plus 1 bracket closed minus 2r plus 2, because I'm going to expand this part. Minus 2 times r will give me minus 2r. Minus 2 times minus 1 will give me plus 2. So let's continue simplifying. That gives us 5r squared minus 2r minus open bracket 5 minus open bracket 5r squared minus 10r plus 5 minus 2r plus 2. So that will give me 5r squared minus 2r minus 5r squared. I'm now opening the biggest bracket, plus 10r minus 5 plus 10r minus 5 plus 2r minus 2. So 5r squared will what? 5r squared will eliminate 5r squared in. Also minus 2r will eliminate what? Plus 2r. So what does that give me? That will leave me with 10r minus 5 minus what? 2. So that gives us UR is 10r minus 7. If UR is 10R minus 7, the question says that we should show that the sequence is a linear one. Let's show that this is a linear sequence. What is the first term? The first term will be 10 times 1. The first term will be U1, and that will be 10 times 1 minus 7. That will give me 3. The second term is U2. That will be 10 times 2 minus 7. That will give me 20 minus 7, 13. The third term is U3. That will be 10 times 3 minus 7, and that will be 30 minus 7, 23. So this forms an AP where the common difference is what? 10. That forms an AP where the common difference is 10. So that solves question A. Now let us go to number 24B. Let's go to question 24B. Let's move on to question 24B. In question 24B, Roman number 1, we are told to find the sum Sn of the first n terms of the sequence whose rth term is 4 times 2 raised to the power minus 1. We are looking for the Sn. We are looking for the Sn of the first rth terms of a sequence. We are looking for the Sn, sum of n terms of the first n terms of a sequence whose rth term ur is equal to 4 times 2 raised to the power minus r. Now this is a very simple question. If ur is 4 times 2 raised to the power minus 1 minus r, it means u1 will be what? It means u1 will be 4 times 2 raised to the power minus 1. That will give us 4 times 1 over 2, and that will give us 2. That will give us what? 2. Now it means u2 second term will be 4 times 2 raised to the power minus 2, which is 4 times 1 over 4, which is what? 1. Since the rth term is ur given by 4 times 2 raised to the power minus r, it means also that the third term will be 4 times 2 raised to the power minus 3, which will be 4 times 1 over 8. 2 raised to the power minus 3 is 1 over 8. That will give us 1 over 2. And the what? And the fourth term, what will be the T4? It means the fourth term U4 will be 4 times 2 raised to the power minus 4, which will give me 4 times 1 over 16, which will give me 1 over 4. So here, we have to find the sum. Now, if you look at this very well, my terms are what? My terms are 2 for the first term, 1 for the second term, 1 over 2 for the third term, and what? And 1 over 4 for the fourth term. On and on like that. This forms a geometric progression. This forms a GP. This forms a GP. A GP is formed. And the first term of the GP, which is my A, is what? 2. Also, the common ratio of the GP will be given by T2 over T1, which will give me what? 1 over 2, which is half. So that means my first term is what? 2, and my common ratio is what? Half. Half is less than 1. You understand? The common ratio here is less than 1. So I'm going to use sum of n terms. You know, the question says I should express the sum Sn of the first n terms. You understand? I should find the sum Sn of the first n terms. So my sum of n terms now, since the progression I've formed is a geometric one, my sum of n terms will be Sn is equal to A open bracket 1 minus r raised to power n over 1 minus r. And that gives me Sn is equal to 2 open bracket 1 minus half raised to power n over what? 1 minus half. That gives me my sum of n terms as 2 open bracket 1 minus half raised to power n over what? Half. 1 minus half is half. 2 over half here will give me 4 open bracket 1 minus half raised to power n, and that gives me 4 times 1, 4 minus 1. 4 times 1, 4 minus 4 times half raised to power n. That will give me 4 minus half raised to power n is the same thing as 1 raised to power n over 2 raised to power n, and 1 raised to power n is the same thing as 1. So that gives me 4 minus 4 times 1 over 2 raised to power n. That gives me 4 minus 4 over 2 raised to power n. And that gives me 4 minus 2 squared over what? 4 is 2 squared over 2 raised to power n. And next will be what? 4 minus, I can express this as 2 raised to power 2 minus n. You understand? 2 raised to power 2 divided by here, 2 raised to power 2 here, divided by 2 raised to power n, can be written as 2 raised to power 2 minus n, like this. So my expression becomes this. So now here, my answer will be 4 minus 2 raised to power 2 minus n. That is the sum of n terms of the sequence. That's the sum of n terms of the sequence. Let's now go to question B. Question B says, question 24b says, I should find the value of n for which the difference between Sn and 4 is less than 10 raised to power minus 4. Question B says, I should find the value of n for which the difference between Sn and 4 is less than 10 raised to power minus 4. So 24b Roman 2 now. I'm looking for the value of n. I'm looking for the value of n for which 4 minus Sn, the difference between 4 and Sn, is less than 1. The difference between Sn and 4 is less than 10 raised to power minus 4. So I'm looking for the value of n for which the difference between Sn and 4 is less than 10 raised to power minus 4. This is the equation I want to solve. My Sn is 4, open bracket, what? My Sn is 4 minus 2 raised to power 2 minus n. 4 minus 2 raised to power 2 minus n. So let's go. Let's do this one by one. So this will give me 4 minus 4 when I open the bracket plus 2 raised to power 2 minus n less than 10 raised to power minus 4. That gives me 2 raised to power 2 minus n less than 10 raised to power minus 4. So here I'm looking for n, so I'll take the log of both sides. 2 raised to power log 2 raised to power 2 minus n less than log 10 raised to power minus 4. Don't forget both are in base 10. So 2 minus n here coming down times log 2 is less than what? Minus 4 times log 10 to base 10. Log 10 to base 10 is what? 1. So that will give me 2 minus n in bracket times log 2 is less than minus 4. So that gives me 2 minus n is less than minus 4 over log 2. So that gives me 2 minus n is less than minus 13.29. So that gives me minus n is less than minus 13.29 minus 2. Minus n is less than minus 15.29. Use your calculator for that step. So when I divide both sides by minus 1, if I divide both sides by minus 1, I will get n is greater than 15.29, and that means the least value, and that means the value of n, that means the value of n for which the difference between Sn and 4 is less than 10 raised to power minus 4 will be equal to 16.